So overall, we have seen that optimization of this vitamin, this pyrroloquinone, quinone. So to varying degrees, inevitable losses of nutritional value occur during the courses of post-harvest handling and then processing, transportation, storage. So such losses occur in all the food processing operations, food service establishment, and also at the home. So it is very important that the nutrient retention is targeted, and it is the responsibility of food technologist or a food manufacturer or a food processor, so that in the mutual interest of consumer as well as the food processor, the vitamins are retained at its maximum capacity. Okay, so maximization of nutrient retention in the home as well as industries or factories or also during retail food services, it should not be overlooked. So many approaches to optimize the vitamin retentions are followed, like based on the physical properties, chemical properties of the particular nutrients involved. And we have seen that, for example, use of acidulants, if compatible with the product, would promote the stability of thiamine. For example, as I gave you an example in thiamine vitamin, ascorbic acid or presence of vitamin C will improve or promote the stability of thiamine a lot. So why not in certain cases add externally ascorbic acid or vitamin C? In some cases, like for example folates, reduction in pH would decrease the stability. However, it illustrates the complexity of this approach. So you have to be very careful. So if you decrease the pH by adding ascorbic acid, thiamine retention will be more, but at the same time, this decrease in the product, if there is also folate, will reduce the stability. So cooking or commercial processing under conditions that minimize the exposure of oxygen, we have seen trying experiment how can we avoid the oxidation by devising equipments or avoiding the oxygen, or instead of using open pan blanching, can you use steam blancher or vacuum blancher, and so on and so forth. So exposure to oxygen, excess liquid lessens the oxidation of many vitamins, and extraction, for example leaching of vitamins, leaching of minerals takes place during various operations. The fourth thing is like use of temperature. Why is use of temperature, like high temperature short time condition will in many instances cause less vitamin degradation than conventional thermal processes, wherein you cook the food for a longer time. Okay, so it's the time is more important. So exposing the juices or fruit or food for a high temperature at a short time will lessen the degradation of the vitamin, and also at the same time it will inactivate the bacteria so that it is safe for the human consumption, and also it has a very good shelf life. In addition to that, certain combination of ingredients can enhance retention of several nutrients, like addition of antioxidants would favor retention of many vitamins. For example, if you add vitamin C, might act as an antioxidant or synthetic antioxidants, but nowadays people want more greener, chemical free, preservative free processing technologies, which can give nutrients, more nutrients, as well as no chemicals you are adding into the human body. So so there are various approaches through which one can do the optimization, like kinetic study, thermodynamics, kinetics of degradation, to the chemical changes, destruction of microorganism, plotting the graph of kinetics of degradation, thermal inactivation kinetics of microorganism, because shelf life of the final product is also ultimately very important, with respect to retention of bioactives. So there are a lot of studies going microbial inactivation kinetics, vitamin degradation kinetics, and its dependency on various factors, rate of Microbillion activation increases as a function of temperature much more rapidly than doses of vitamin degradation. So one has to work parallelly, and one has to predict the losses. Like predicting the magnitude of losses of vitamin require accurate knowledge of degradation kinetics and temperature. For example, suppose I have studied, okay, amla juice, okay, so I this is the temperature and then this is the degradation. So as the temperature increases, there is a degradation, okay, of this vitamin. So I know that at 80 degrees celsius or 70 degrees celsius there is a almost 100% loss. So how can I modify my processing so that the temperature is low, at the same time I'm not losing on the consumer acceptance or sensory, and also the product is microbiologically safe, rich in vitamin C. So, accurate knowledge of degradation kinetics and temperature dependence of the particular form of the vitamin is considered in the chemical milieu of the foods. Like different forms of vitamins are present. We have seen there is a synthetic form, there is one form, other form, pyridoxal, pyridoxine, pyridoxamine. So they are different forms which react differently to various food composition and to various processing conditions. So one has to be very careful while designing such studies. One must determine whether kinetic studies of total content, like sum of all forms you are determining, or you are determining only specific form. Okay, so more specific information on the various form of vitamin is needed, and lot of studies and research is still going on. Processing studies must be conducted under conditions which are identical to those prevailing during the actual commercial processing. See, suppose I am performing an experiment in the laboratory, so that should be implemented directly to the commercial processing. It should not be the experiment that only is possible into the laboratory. So it should be like actual commercial processing or storage condition being modeled because of the sensitivity of many nutrients to the chemical and physical environment. So reaction kinetics should be obtained at several temperatures. It should not be done like I have done at 50 degrees Celsius, then 100 degrees Celsius and 150 degrees. It should not be like that. So it should be done like several temperature, like 10, 20, so that actually the degradation taking place, one should be able to identify. It should be like time also and temperature also. So it should be obtained at several temperatures, several time, to permit the calculation of rate constant and energy activation. So you get a very good graph and no point is missed in between. Okay, so the experimental condition should be selected to provide the sufficient loss of vitamin being studied, so that the rate constant can be determined with the appropriate accuracy. Also, there are studies wherein accelerated storage studies are performed with respect to each vitamin. Lot of studies are going on. Also, there is a effect of storage temperature and extrinsic factor, intrinsic factor, but at the same time packaging material plays a very important role in vitamin stability. Like in canning foods that transmit heat energy primarily by conduction, like solid or semi solid, will undergo overall loss of nutrients, undergo a greater loss than food that transmit heat by convection. So whether it is a conduction of transmission of heat energy or convection. Okay, so difference is caused by the requirement that thermal process must be based on the slowest to heat portion of the product, which for conduction heating food is geometric center. Like for example, in the autoclave I'm heating, so the heat should reach at or a center point of the container that I'm using. Such losses are minimized by using container with the large surface. For example, that is why retort pouch processing are coming. So cannings are not recommended. Small cans, non-cylindrical condensers are replaced with the retort processing pouches. So these pouches also offer the advantage of requiring less liquid for filling. Also leaching during processing of particular food can be minimized. So there are a lot of advantages of these packaging material. The permeability of this packaging material can also have a substantial effect on retention of vitamin. Ascorbic acid in juices, fruit beverages also shown to exhibit greater stability. And there are a lot of